बिस्मिल्लाहिर्रहमानिर्रहीम। चैप्टर नंबर 7 है स्पेशलिटी मशीन्स, यानी कि इसको आप ये कह सकते हैं कि स्पेशल मोटर्स। ठीक है जी, मशीन्स के अंदर स्पेशल मोटर्स जो डिस्कस की हुई हैं चैप्टर नंबर 7 में। तो हमने कुछ मोटर्स चैप्टर नंबर 6 में भी स्पेशल पढ़ी हैं, सिंगल फेज इंडक्शन मोटर थी। तो यहाँ पे कुछ सिंक्रोनस मोटर डिस्कस की हुई है चैप्टर नंबर 7 में, और कुछ डिस्कस की हुई है सिंक्रोनस मोटर्स, और कुछ एक मोटर हमारे पास डिस्कस हुई है हाइस्टेरेसिस के फिनोमेना पे। ठीक है, तो इंडक्शन मोटर भी हमारे पास डिस्कस है चैप्टर 7 में, लीनियर इंडक्शन मोटर। अच्छा, हाइस्टेरेसिस मोटर भी डिस्कस है जो हाइस्टेरेसिस के फिनोमेना पे काम करती है, और ये आपकी असाइनमेंट है, ये आपने करनी है। रिलेक्टेंस मोटर है हमारे पास, ये 7.2 जो फर्स्ट आर्टिकल है, रिलेक्टेंस के फिनोमेना पे काम करती है जिसके थ्रू मैग्नेटिज्म होती है। रिलेक्टेंस तो हम डिस्कस करेंगे इस मोटर को। उसके बाद स्टेपर मोटर है, वो भी कराते हैं, आप उसको भी देख लीजिएगा। और लास्ट हम कराएंगे यूनिवर्सल मोटर, जो कि इस चैप्टर का लास्ट टॉपिक है। तो ये स्पेशल मशीन्स कोर्स के अंदर इंक्लूडेड है, और बेसिकली यही मोटिव होता है कि मोटर्स की जो वैरायटी है, थोड़ा सा हम उनके अंदर हमारा इन डेप्थ हमारा इनसाइट व्यू हो जाए उसका, और अंडरस्टैंडिंग हो जाए, ताकि जो है हम जरा अंडरस्टैंड कर सकें जो फिनोमेना पीछे पड़े हैं सिंक्रोनिज्म वाले, पुल इन वाले, पुल आउट वाले, वो कैसे इन मोटर्स के अंदर अप्लाई होते हैं। ठीक है, तो बेसिकली है, तो थोड़ा सा हम इसको डिस्कस करते हैं। फॉर एग्जांपल हम स्टार्ट करते हैं जी इंट्रोडक्शन से। कहता है कि मशीन्स सच एज रिलेक्टेंस मोटर्स एंड हाइस्टेरेसिस मोटर्स आर यूज्ड फॉर टाइमिंग डिवाइसेस। मैंने कहा था कि हर मोटर की पार्टिकुलर एप्लीकेशन के लिए इस्तेमाल होती है, तो एप्लीकेशंस को देखकर आपके जहन में आ जाए कि इसमें ये मोटर इस्तेमाल होगी। फॉर टाइमिंग मशीन्स, टेप रिकॉर्डर्स, टर्न टेबल्स एंड अदर्स फॉर विद कांस्टेंट स्पीड रिक्वायरमेंट। तो कांस्टेंट स्पीड कैरेक्टरिस्टिक्स आ जाई तो जहन में आ जाना चाहिए कि इसमें जो कौन सा फिनोमेना इस्तेमाल होगा, क्योंकि वेरिएशन नहीं है, लोड वेरिएशन नहीं है। जब लोड वेरिएशन नहीं होगी तो इंडक्शन होगा, इंडक्शन। ठीक है जी, फिर इंडक्शन के अंदर देखना चाहिए फिर कौन सी किस्म है, तो ये रिलक्टेंस और हाइस्टेरेसिस मोटर्स हमारे पास कांस्टेंट स्पीड कैरेक्टरिस्टिक्स के इस्तेमाल होती हैं। आगे स्टेपर मोटर आएगा। स्टेपर मोटर्स आर इन कंजंक्शन विद पल्स ड्राइविंग सर्किट्स फॉर प्रिसाइज पोजिशनिंग ऑफ द मैकेनिकल सिस्टम्स। यानी कि आप फोटो वो करते हैं, प्रिंट आउट लेते हैं, तो प्रिंट आउट के अंदर जो स्टेप बाय स्टेप पेज को बाहर निकालता है, लेकर जाता है, स्टेपर मोटर्स है। ये और किसमें इस्तेमाल होती है? प्लॉटर्स, प्लॉट करने के लिए, कलर प्लॉटिंग के लिए, कोई डिवाइस की प्लॉटिंग करने के लिए, प्रिंटर्स के अंदर, डिस्क ड्राइव्स के अंदर ये स्टेपर मोटर्स इस्तेमाल होती हैं। लीनियर इंडक्शन मोटर्स आर यूज्ड टू अप्लाई मैकेनिकल फोर्सेस एंड टू कॉज मूवमेंट्स इन स्ट्रेट और कर्व्ड लाइंस। अब लीनियर इंडक्शन मोटर जो है इनकी मूवमेंट कराती है, हमारे पास मैकेनिकल फोर्सेस जनरेट करती है, जिसकी वजह से मूवमेंट होती है स्ट्रेट लाइन में। आप ये कह सकते हैं कि हमारे पास जो है अगर फिनोमेना स्ट्रेट लाइन की मूवमेंट का, कर्व लाइन की मूवमेंट का, रेलवे ट्रैक्स जो इलेक्ट्रिकल रेलवेज होती हैं, ट्रेन होती हैं, उनके अंदर हम देख सकते हैं कि ये फिनोमेना अप्लाई हो सकता है। डोर ओपनर्स, कन्वेयर सिस्टम्स में इस्तेमाल होते हैं। एयरक्राफ्ट लॉन्चर्स, इलेक्ट्रोमैग्नेटिक गन्स, लिक्विड मेटल पंप्स फॉर न्यूक्लियर रिएक्टर्स, हाई स्पीड रेल ट्रांसपोर्टेशन। देखा, हाई स्पीड रेल ट्रांसपोर्टेशन, इसकी दो एग्जांपल्स हैं। एक यूके के अंदर है, शायद यूएस के अंदर भी होगी, और चाइना के अंदर इसकी बहुत फेमस एग्जांपल है। ये आप जाके इसको आज देख लीजिएगा, इसको सिर्फ लिख ले कि हाई स्पीड रेल ट्रांसपोर्टेशन इन चाइना, तो ये आपके पास पूरा का पूरी वीडियो जो है वो उसको डिस्प्ले हो जाएगी, जिसमें ये बताया जाएगा कि ये कैसे होता है, सिमिलर कैरेक्टरिस्टिक्स है। ठीक है, तो ये मोटर्स भी है हमारे पास। फिर यूनिवर्सल मोटर्स हैव वाइड एप्लीकेशंस इन लो पावर apparatus such as वैक्यूम क्लीनर्स, स्मॉल पावर टूल्स एंड किचन अप्लायंसेस। तो पहली मोटर हम डिस्कस करते हैं रिलेक्टेंस मोटर्स। ठीक है, फिगर के अंदर डिस्कस की हुई है। दिस रिलेक्टेंस मोटर का जो रोटर है, इस रोटर हैव नॉचेस, फ्लैट्स और बैरियर स्लॉट्स। बैरियर स्लॉट्स से डिस्कस करें, दे हैव स्लॉट्स प्रोवाइडेड इक्वल स्पेस्ड एरियाज ऑफ हाई रिलेक्टेंस। जो ये स्लॉट्स होंगे ये हाई रिलेक्टेंस प्रोवाइड करेंगे, किस लिए? फॉर द हाई रिलेक्टेंस एरियाज आर कॉल्ड सेलिएंट पोल्स टू इन ऑर्डर टू प्रोड्यूस द रिलेक्टेंस टॉर्क। टॉर्क पैदा करने के लिए, ठीक है, सिंक्रोनिज्म पैदा करने के लिए हमारे पास, रिलेक्टेंस टॉर्क को पैदा करने के लिए हमारे पास डिजाइन के अंदर, रोटर के अंदर स्लॉट्स स्पेशली डिजाइन होंगे जिसमें हाई रिलेक्टेंस होगी। नंबर ऑफ द सेलिएंट पोल्स, ठीक है जी, जो स्लॉट्स हैं मस्ट बी इक्वल टू नंबर ऑफ स्टेटर पोल्स। रोटर पोल्स और स्टेटर पोल्स आपस में बराबर होने चाहिए। When the stator is energized, the rotor accelerates to squirrel cage induction motor. ठीक है जी, squirrel cage induction motor क्या मतलब हुआ हमारे पास यहाँ पे? इसका मतलब ये है कि no variation of the R by X, no variation of the resistance, no variation नहीं हो सकती resistance की, तो squirrel cage induction motor रन करेगी. As rotor approaches synchronous speed, the slip is very small, slip 0 हो जाएगी, and the rotor rotating flux of the stator moves slowly past the cylinder poles of the rotor. ठीक है, at some critical speed, the low reluctance paths provided by the salient poles cause them to snap into the synchronism with the rotating flux of the stator. Rotating flux of the stator. When this occurs, the slip is 0, induction motor action ceases, and the rotor is pulled out by simple magnetic attraction called reluctance torque. ठीक है जी, ये आप देखिए रोटर है हमारे पास, ये रोटर के पोल है. दिस इज द नॉच. अ नॉच इज अ स्लॉट मेड inside the rotor that has areas of the high reluctance. ठीक हो गया. और ये poles हैं, they have a low reluctance area, so there is a reluctance variation inside the design of the rotor in order to produce the magnetic attraction phenomena for the rotor to catch up into the synchronism for the stator rotating magnetic field. ठीक है, अब ये हम देखेंगे. दिस इज द रोटर पेरिफेरी. ये रोटर पेरिफेरी है हमारे पास. दीज आर द स्लॉट्स, दीज आर मेड. ठीक है जी, एंड दीज आर दी low reluctance areas. The slots are the flats notches with high reluctance area. ठीक हो गया. And when the stator is energized, the stator produces rotating magnetic field north to the south. तो rotating magnetic field है that is induced inside the rotor. रोटर की भी फील्ड प्रोड्यूस होगी at no load. The first case is at no load. At no load means NR is equal to NS. Both are equal. So what's the angle here? 0. No lag, no lead. Angle is 0. Similarly, when a certain partial load is applied on the motor, so the rotor poles will lag the stator poles by a certain angle of lag that is called as the del. Power angle or angle of lag or torque angle, this is called as the reluctance angle. Del is the lag of the reluctance lag or del reluctance, that is power angle. ठीक है जी, by a certain angle. ठीक है. If the load is further increased, maximum load, it will the lag angle will further increase. The maximum value is up to 45 degree. This 45 degree is the maximum value of the lag angle. Above this, if the shaft load is further increased to the value greater than 45 degree, or the load is further applied, what will happen? It will pull out of the synchronism. Why this threshold is 45 degree? This threshold is 45 degree. Why? Because the relation of the reluctance torque of the reluctance motor in equation 7.1 is 2 del. 2 del. So 2 del means 90 degree. 45 degree, and 45 into 2 is 90. So 9 sine of 90 is 1. If it increases a single point beyond 45 degree, 45.1, 45.2, it will pull out of the synchronism. Why? Because the sine of 90 is 1. When the value of 90 will increase, it will cause the rotor to pull out of the synchronism. So this is the relation of the reluctance torque that is generated by the reluctance motor. That is the constant K, voltage applied V, frequency of the voltage F, whole square into sine of 2 del at slip 0 when it comes near to the synchronism. So this is the average value of the reluctance torque expressed in terms of the applied voltage, applied frequency, and torque angle. This is the equation, right? If it is further increased, then it will come out of the synchronism. So again he discusses that a pull out torque, the maximum torque is only 45 degree. The constant speed characteristics of reluctance motor, their simple construction, ruggedness, partially low cost. Why? Because simply you have to put the rotor designing into the structure and then you are good to go. They are desirable for more economical timing devices, turntables, tape recorders. So in exam the questions may come for various applications which type of motor is used. So you must know They are also used in automatic processes such as found in food processing and packaging industries. Food processing and packaging industries. Synthetic textile industries, they are used that are used as many as 90 to 100 machines, each driving different sections of the production line, be operated in synchronism over a wide range of speeds. Okay, up to 45 degree you can vary it. Three phase reluctance motors. This is single phase. You can design a three phase reluctance motors rated at 100 horsepower and more are used in large power applications where the complexity and cost of standard synchronous motors are not warranted, because the cost may go high and the efficiency and the quality of the delivery is a question when you design a three phase electric motor. They can be designed. They can be designed. The rating is up to 100 horsepower. So you must know that simple they are used in these devices, and for high power rating they are used for our power applications, right? Example 7.1 is a very simple example. It says a certain 10 horsepower is the mechanical output, 4 pole 240 is the input, 60 hertz frequency reluctance motor. So reluctance motors means single phase reluctance motor operating under rated conditions. So these are the rating values, right? Has a reluctance torque. Torque means del 30 degree. Determine the torque load on the shaft. Torque load on the shaft, you do not know, you have to find the torque load. Torque load means torque reluctance torque that has to be generated to cater out the load on the shaft. Torque angle. Torque means del. If voltage drops to 224, if the voltage drops, it means you have to use again divide formula. Will the rotor pull out of synchronism? It means you have to find the value of torque angle. If torque angle is less than 45 degree, it will not pull out of synchronism. So you have the values of these unknown parameters. Unknown parameters. NS is equal to 120 F by P. Straight away it is 1800 RPM. Torque, you have to find torque. This is a famous formula. P shaft is equal to Tn 5 by 2 5252. So T reluctance will come 29.18 with same torque load and constant frequency, because he says that only voltage drops to 224. Only voltage drops to 224. It means that a frequency remains constant and torque remains constant. So this is the formula that was previously we studied. V square sine 2 del divided by F square. So F square is not needed here. So V sine 2 del reluctance 1, this is for the rated conditions, is divided by this is equal to T reluctance 1 divided by reluctance 2. So they are since constants, they will be cancelled out, and 1 is equal to 2. So V square sine 2 del reluctance 2. This will be the final conditions. These are the additional rated conditions. You will find out the reluctance torque 41.9, 42. So less than 45 degree, it will not pull out of the synchronism. This is a very simple example. Second you will do is only for the paper preparation is hysteresis motor. It is basically this motor is basically designed for the hysteresis phenomena, magnetization and demagnetization of the hysteresis core, right? When you apply the AC signal to it. So this is simple. You will study it. Very simple. Hysteresis losses, and this is the relation of the mechanical power and torque. Hysteresis torque it will develop, and you will make it. It is not so difficult. So right, and this is the curve related with this one. So this is your home assignment. What is the last motor that we will study for this course only in the class? That is universal motor, right? So universal motor. The name universal comes because of the wide range of universal applications. The first reason is this one. The second reason is that it is used for AC as well as DC applications. That's why it is called as universal. So the first sentence says the same concept. A universal motor is relatively small series motor. Why it is called series we'll discuss. Specially designed to operate at approximately the same speed and output power on either DC or single phase AC at frequency of 60 Hz or less, right? AC पे भी operate, DC पे भी operate करता है. Such motors have rating from 0.01. It means 1 millihorse, 10 millihorsepower, 10 millihorsepower to 1 horsepower at the rated speed. So rated speed is 5000 rpm. So it's a small motor that can be designed for large size as well. 5000 rpm or above. Or above means 5000 to 12,000 rpm. Speed goes to 12,000 rpm. An elementary universal motor is shown in the figure. We will discuss the figure. It has a rotating part. The rotating part in DC is called as armature, connected in series with the series pole. We will show you the poles. The rotating commutator, that is a switch. Commutator is a mechanical rectifier, convert AC into DC. It is a switch. And stationary brushes that are with the commutator constitute a rotary switch that reverses the direction of the current in the armature coil as coil rotates. Okay. The direction of the developed torque and hence the direction of the armature rotation is independent of the polarity of the AC, as it operates on AC as well as DC. So DC as well as AC and DC. So whether you change the polarity or you keep it the same, the direction of the developed torque clockwise or counterclockwise, and hence the direction of the armature rotation clockwise or counterclockwise, is independent of the polarity of the AC source. Why AC source? AC changes the polarity, and you have used the commutator, and commutator converts this phenomena of AC polarity changing into constant frequency, right? So that's why he says that it remains same. This is shown in figure 7.18. We will show it. The developed torque is equal to flux density into armature current. BP is the flux density into armature current, and we know that a flux density is again proportional to proportional to armature current. So to develop torque is directly proportional to square of the armature current. It means that if you double the armature current, the developed torque will increase 4 times. So it means that universal motor can develop high torques, can accelerate at higher speeds, and have high power to weight ratio than induction motor of same ratings. Okay. Reversing direction of the rotation of the rotor motor is accomplished by reversing the direction of the current in the series field or in the armature, but not in the both. एक चीज में रिवर्स करेंगे, दोनों में रिवर्स करेंगे तो वो उससे फर्क नहीं पड़ेगा, ठीक है. लेकिन अगर कम्यूटेटर से पहले कर लिए तो फर्क नहीं पड़ेगा, बिकॉज कम्यूटेटर कीप्स द थिंग्स polarity of the voltage and the current direction same. Speed adjustment is accomplished by using an auto transformer. You can use auto transformer as well for voltage control, okay, or solid state control. Solid state control means AC DC DC drives for to reduce the voltage applied to the rotor. Reducing the applied voltage reduces the armature current, which reduces the developed torque and hence reduces the speed. So voltage कम होगी, current कम होगा, developed torque कम होगी तो speed भी कम होगी. The torque and the speed characteristics of the universal motor are essentially the same, whether AC or DC. That's why universal. Furthermore, because of its relatively small dimensions, no load speed in excess increases to the speed of 12,000 rpm and achieved without damage. Universal motors have applications in vacuum cleaners. Vacuum cleaners में इस्तेमाल होते हैं, high speed होती है, portable power tools and kitchen appliances. Series motor, this universal series motor operating from 25 Hz single phase system are used for electrical railroads. We can see here, this is the winding that are, these are the poles, north, south. These are the series winding. This is why they are called series wound, because they are wound with the wound in series with the armature. The armature is in series with the winding. That's why it's called series field winding. Series field winding because these are the windings are in series with the armature. You apply the AC supply, you can apply DC as well. This polarity change does not affect directly in start because the commutator is there. The commutator is connected with the carbon brushes, and the carbon brushes, you whether apply AC, whether apply DC, they will produce a constant operation. The direction will not change. The direction can only be changed if you change the direction of the current in the armature. If the direction of the current changes in the armature, then the direction of the rotation or torque will reverse, otherwise remains same. The phenomena is same when you apply current. The current will produce a field, and whenever a current carrying conductor is placed in a magnetic field, force acts upon it. Force acts on one side, side of the coil upwards, for example, B side is downward, then the rotation will be occur. This is the equivalent diagram of the universal motor. This is the armature rotating section. It has a series field winding. That's why it's called series. Field winding is in series with the armature, and you apply a source. Okay, so this is the simple working operation of the um, universal motor. So for paper preparation and for the course preparation, reluctance torque is included. Hysteresis motors, reluctance motors are included. Hysteresis motors are included, and lastly, universal or series motor is included, right? So you have to prepare this one. So that finishes our course. Inshallah, we will meet in the final exam.